Today we finish out our last day of notes on writing quadratics, and today we'll be doing all forms. So we've done various forms of standard, vertex, and intercept. Today the focus is going to be on doing all of those and understanding how we move between them. So I know you know how to do pretty much all of this, but I'll go through some of the notes if you're not feeling comfortable with it. If you are, I would encourage you to go ahead and just try it on your own and see if you can work through the notes, because really there should be not much of anything new today. It's just practicing and seeing everything kind of all put together at once. So if you're comfortable with it, then try it out on your own and just come back and skip to a part in the video if there's something that you have trouble with and want to see me do a certain problem. So I'm going to go through all of this, but you do not have to watch with me and do every bit step by step. So we have a graph for the first problem, and it says to write in all three forms. We have several pieces of information that are going to be important. The first is that our vertex is at 4, -4. That's going to be important to write vertex form. Our intercepts are at 2, 0 and 6, 0. That's going to be important for writing in intercept form. And then we see that, as we looked at yesterday from reading from graphs, our growth rate is just our normal parent function growth rate. We go over 1 and up 1, or over 2 and up 4. So we're growing at a rate of y equals x squared, so our a value is 1. So we have everything we need to write intercept form and vertex form. Let's start with vertex. We have y equals 1, because it's opening up and a is 1. And then x, let's see, minus 4, because we have a positive 4, x minus 4 squared. And then minus 4. So that's our vertex form. Intercept form is y equals a, still 1, so times x minus our first 0 is 2, times x minus our second 0, which was at 6. And then to get to standard form, we can just expand either of these. I think intercept form here looks a little easier because there's no collecting like terms. So we can use the area model or double distribution to multiply these two binomials together. So since this is the first problem, let's go ahead and just remind ourselves how to do that. So x minus 2, x minus 6. We get x squared minus 6x minus 2x plus 12. So we just combine those two on the diagonal and get y equals x squared minus 8x plus 12. Or if you prefer double distribution, we do x minus 2 times x minus 6. We distribute the x to both of those and the minus 2 to both of those and get x squared minus 2x minus 6x plus 12, which is the exact same result, just by a different visual format. So that's it. That's how we can take a graph and easily find all three forms, provided the zeros are at integer values. If these zeros weren't at integer values, we wouldn't write an intercept form necessarily, because it's not factorable. Okay, so convert the function from intercept to standard and vertex. Great, so we have an intercept form. We have an a value of 2, and our zeros are at -1 and -13. So standard form is really easy. We just distribute. The key thing to remember here is that this 2 does not distribute to every other thing. What you should do is combine the two binomials first and then distribute the 2. So if we do x plus 1 times x plus 13 and then deal with the 2 later, we have x squared plus 1x plus 13x, so that's plus 14x plus 13. Then we'll distribute the 2 to each of those things. So our standard form is y equals 2x squared plus 28x plus 26. Then our vertex form, we're going to need to find the coordinates of our vertex. We know the x part is halfway between -1 and -13. So we're going to average -1 plus -13 over 2 is going to give us -7, comma something. Then we're going to plug that -7 into one of our two forms that we have to find the y coordinate. I'm going to plug it in here because I think it's easier to plug into intercept form. I don't have to worry about squaring anything. So if I plug in my -7 here, we get 2 times -7 plus 1 is -6. -7 plus 13 is 6. And those two should pretty much always come out to be the same for the vertex. So we have 2 times -36. So that's -72. Wow, that's way down there. Okay, so we have -7, -72. And that lets us write our vertex form. Because again, we know that A is, what is it? A is 2, right? Because it was given here as 2, and we see it here in our standard form as 2. So y equals 2 times, then we'll have x plus 7, because we're taking the opposite of our h here, squared, and then minus 72. So that's how we can get from intercept form to both standard and vertex. Next one, we have our vertex and a point given, and we need to find all the forms. So first thing, we know that our vertex form looks like y equals a times x minus h squared plus k. Currently, we know h and k and x and y. So that gives us 4 out of our 5 variables, and that lets us solve for a. So this is a great place to start so that we can find out what a is. If we tried to start with any other form, we wouldn't have enough information. So the fact that they gave us the vertex is our key that vertex form is where we want to start. So let's plug in these 4 values. Y is 0. We don't know a. We're going to solve for that. X is 3 minus, that's a bad 3, minus h was 2. We're going to square that. And then k is -2. So we're adding a -2, which is the same as -2. All right, so if we solve this, 3 minus 2 is 1. 1 squared means we have 1a. So 0 equals 1a minus 2. Move the 2 over there. A equals positive 2. So our vertex form, y equals 2 times x minus 2 squared minus 2. Now we can turn that into standard form. So standard form, we're going to just distribute everything. So you know how to do x minus 2 squared. Do that first, then multiply by 2. Don't distribute the 2 first. Do x minus 2 squared, exponent first, then distribute the 2, and then subtract 2. You're going to come up with y equals, so that's going to be 2x squared. Then here we would have had minus 4x, double it is minus 8x. And then plus 4 times 2 is 8. 8 minus 2 is plus 6. So you can write out all the work for that. You know how to do it. We've been doing this for quite a while now. So I'm just going to go ahead and shortcut it and do that in my head instead of writing it all out. Now to get to intercept form, we want to try to factor the standard form. So we have 0, since we're trying to find the intercepts, we set y equal to 0, equals 2x squared minus 8x plus 6. It'll make life way easier if we take out the GCF first. So we're going to divide everything by 2 and rewrite this as 0 equals x squared minus 4x plus 3. So we need 2 numbers that multiply to make 3 and add, because this is a plus, to add to make 4. So our factors are, I guess, since a is 1, I can kind of skip to the answer, but a is not always 1, so let's do all the actual steps. So I'm going to draw the area model here, and we have x squared, and we have 3, and then we're trying to make -4x, and I find that my factors that do that are 1 and 3. And since it's a -4, I need minus x and minus 3x. So I look for my GCFs. I can take out x here, I can take out x here. Then this is a -1, and this is a -3. So my factored form is x minus 1 times x minus 3. But remember, I took that 2 out earlier, so that a value that we see in every form of the equation is still going to be out here when we get to the end and write it back as y equals 2 times x minus 1 times x minus 3. So you'll always see that when we write all three forms, this 2 appears in all of them. So whatever the a value is, all three equations have that in common. So it's kind of nice to see them side by side and see that 2 repeated like that. Okay, so next one, we're going to write from standard form into vertex form. Now, we haven't really talked about how to find the vertex from the standard form, but there is a really handy shortcut that's on your star chart, and it tells you that the h, the x-coordinate of the vertex, is at -b over 2a. So this is as good a place as any to kind of introduce that. It's a way to find it without going through the intercept form to find the zeros first. Let's see, can we even factor this? If we're trying to make 32 by multiplication and 12 by addition, that would be 8 and 4. So just looking at it, if we had our factored form, x plus 8, x plus 4, then our zeros are -8 and -4, meaning our h value is the average of -8 and -4, which is -6. So I just did that so we can see if this little shortcut is going to give us the same result. So b is the coefficient of the x term, so our h should equal -12 divided by 2 times our a term. Remember, a is the one in front of the x squared. So divided by 2. That gives us -6, which is the same result that we would get by factoring. It's just much faster. So this one, if you don't have to memorize it because it's on your star chart, but it is a really handy shortcut to know to get to your vertex from standard form without going through intercept. And this one works even when this one doesn't factor. So if we have a standard form equation that can't factor, we can still find our vertex by using this little shortcut. So now that we know our vertex is at -6 comma something, we can plug that back into our original equation. -6 squared is 36, plus -6 times 12 is -72, plus 32. So 36 minus 72 plus 32 gives us 68 minus 72, so that equals -4. So that's our y coordinate. So this is just plugging in our value and evaluating to find the y coordinate. Now that we have that, we know a is 1, right? Because there's nothing in front of x squared. So our equation, I'm going to write it in a different color here. Our solution is going to be y equals a, which is 1, times x minus h, so we'll get x plus 6 squared, minus 4. So I did more work there than was necessary, so to kind of focus in on exactly what we needed to do. Step 1, take standard form, use h equals -b over 2a to find our x-coordinate of our vertex. Take that x-coordinate, plug it into standard form to find the y-coordinate, and then use a and the vertex to write our equation. All right, so now we have a table of values. We want to write standard and vertex. They don't ask us to write intercept, so I'm guessing that it doesn't have good intercepts. Looking at the table, the main thing when I'm looking at a quadratic table is I want to find where the vertex is. So I see my y values are decreasing to -4, and then they turn around and start mirroring the values the other direction. So this right here, where it turns around, is my vertex. And since the numbers are the same on both sides, it's exactly at that point. So 2, 4 is my vertex. So my next question, I know my vertex form looks like y equals a times x minus 2 squared plus 4. I need to find a, so I have a couple of ways of doing that. The first way is to take any point other than the vertex and plug it in. So like this 0, 8 would be a great one to plug in. And then we could find a. We also talked about in graphing that you can use the expected growth rate for the parent function and compare it. So if I go plus 1 and plus 1, and then I go plus 2 and plus 4, that's my standard parabolic growth rate. So I know that my a value has to be 1. But you can also find it by plugging in a point. That would work just fine. Okay, so now we're going to look at our vertex form equation as y equals 1 times x minus 2 squared plus 4. And then we can expand that out to do y equals x squared minus 4x plus 4 plus another 4, so plus 8. So remember, you can use your area model or double distribution, but really, really important, do not miss out on this minus 4x. When you square x minus 2, do not just try to distribute this 2 to those two pieces. You have to include the middle term either using the area model or double distribution. So x minus 2 times x minus 2. Very, very important, and it's the easiest, most common mistake to make on quadratics is to miss this middle term, so please, please don't do that. Okay, so number 6, we want to rewrite this one in vertex form. So we're going to use our same trick as up above, where we know the x-coordinate of the vertex is negative b over 2a. That's the one from our star chart. So we know that it's negative 4 over 4, because b is 4, and then a is 2. We double that and get 4. So our h is negative 1. Then we need to find the k value, the y of the vertex. So we're going to plug in negative 1 to this equation. So this is 2 times negative 1 squared plus 4 times negative 1 minus 6. Negative 1 squared, remember, is positive 1. So this is 1 times 2, that's 2, plus 4 times negative 1, that's minus 4, and then minus 6. So 2 minus 4 minus 6 is negative 8. So now that we know our vertex, we also, remember, know our a value. That's all we need to write the equation as y equals 2 times x plus 1 squared minus 8. All right, so then we've got a vertex and a y-intercept. That's exactly the same as a vertex and a point. And we want to write this one in standard form. So we'll start off with vertex form, and I'm going to go ahead and directly substitute in. Remember, this is h, k, and x, y. So negative 3 equals a times x, no, not x, 0. A times 0 minus 2 squared minus 1. So I have negative 3 equals a times negative 2 squared is 4, so that's 4a minus 1. Move the 1 over to the other side. We have negative 2 equals 4a. So a is negative 1/2. So we've got our standard form is our vertex form, let's write that first, is y equals negative 1/2 times x minus 2 squared minus 1. Now we're going to expand that out, so we get y equals negative 1/2 times, remember to FOIL this out, or not FOIL, but double distribute or area model so that you don't miss a middle term. X squared minus 4x plus 4 minus 1. So now we're going to distribute this minus 1/2, and we'll get y equals negative 1/2 x squared. Then negative 1/2 times negative 4x gives us plus 2x. Negative 1/2 times 4 is minus 2, and we'll combine that negative 2 with the negative 1 to get our final standard form answer. So as a reminder, in standard form for quadratics, we can have a negative a value, we can have a fractional a value, that's okay. In linear equation standard form, we said those weren't allowed, but those are certainly allowed for quadratic because there's no way to get rid of those and still keep it as y equals. So this is the thing that's important. It has to stay just one y on this side, so there's no way to get rid of this negative 1/2 without changing the y as well. Okay, so we have another table. We have a y-intercept of 7, so that's here. So yeah, you probably already tried this, but 0, 7. A vertex of 2, 3, so at 2, we're at 3. So since that's the vertex, we know that it turns around and goes the other way. So there must be another 4 to match this one, and then another 7 to match this one over here. Okay, so vertex form, we know our vertex is at 2, 3, and our y-intercept is at 7. So really, this is exactly the same as problem number 7, where they give us a vertex and a y-intercept. We're going to follow the exact same steps. So I'll go through and do those really quick. Hopefully you've already taken a shot at it. So we have our y value. I'm going to use our y-intercept again because there's a 0 for x. So we have 7 equals a times our x value of 0 minus 2 squared plus 3. So that's 7 equals 4a plus 3. Take away 3, a equals 1. So we get y equals a, which is 1, times x minus 2 squared plus 3. And then converting that into standard, we're going to get y equals x squared minus 4x plus 4 plus 3, so plus 7. And remember, this c term of standard form is our y-intercept, so we can see that directly right there. All right, so we've got some more practice to do. I think that I'm just going to skim through these and see if they're the same kind of problems. So we have standard form with these x-intercepts. So we've definitely done practice like that, but not today. So let's go ahead and do y equals, and remember this is a times x minus p times x minus q. That's our standard intercept form. And we know the point, this gives us an x and y, and this gives us p and q, our two zeros. So we can plug everything in and get 8 equals a times 3 minus 2 times 3 plus 4. Yep. And then that's going to give us our a value. So 8 equals, this is 1 and 7. Really? Those are weird numbers. So it looks like we have 7 times 1, so 7a. So that means we're going to divide both sides by 7 and get a equals 8/7. It looks really weird, but seems right. So then we can write our intercept form as y equals 8/7 times x minus 2 times x plus 4. We can distribute these or do the area model, and then we'll get y equals 8/7 times x squared minus 2x plus 4x, so plus 2x minus 8. And then distribute here to write standard form. So we end up with our answer as y equals 8/7 x squared plus 16/7 x minus 64 over 7. Okay, well that's a number right there. Okay, so this one says write in standard and vertex form. So we know all the steps to do that. We find our vertex by averaging our zeros, and then we know how to write standard. So I'm going to skip that one. It'll be on the key if you need to look it up. We have another graph one, which is where we started today. So I'll do one more of these, and then I'll skip the rest of those. Our vertex is at -4, 6. Our y-intercept is 0, -2. So we know that that's enough information to write everything, right? Like we can already do all the things from just that. And our zeros, in fact, look like they're at halves. So it looks like -7.5 and -0.5. I can't be sure it's exactly there, but that's what it looks like. Okay, so let's start off with vertex form. We're going to, I'm actually just going to find the a value from the graph instead of plugging in. You can plug in like we've been doing up above, use these two to find the a value, but I'm going to look at my graph, and I have this point here. To get there, I go over 1, 2, 3, 4, and I go down 6, 7, 8. So thinking about my parent function, if I go 4 units over, then I should go down 4 squared. So I would expect to go down 16 units, but I only went down 8. So 8 over the expected 16 means my a value is 1/2. So my vertex form is y equals 1/2, and then we've got x plus 4 squared plus 6. Okay? Then we're going to just expand that out into standard form. We get y equals 1/2 x squared. This is plus 8x, and 1/2 of that is plus 4x. This is plus 16. Half of that is 8 plus 6 plus 14. All right, so that's how we do the graph ones. Remember that instead of this kind of intuitive way I just did here, you don't have to do that. You can do the exact same way we did up above, where we were given a vertex and a y-intercept. That's all the information you need to plug in h, k, x, and y, and that will get you the exact same result of a being 1/2. I just prefer this way because it's very visual, which goes with the graph, and it's kind of faster and more intuitive than plugging everything in. We've got another one here where we're doing all 3 forms from a graph. I'm going to skip that. Write in vertex form, so we're going to use our -b over 2a shortcut here to find h, and then we've done a bunch of problems like this already today, so you can follow through on that one. We have a table of values, so remember our key there is to find our vertex. So we have our y values turn around right here. So our vertex is at 4, 9. And then from that, we can use the vertex and the y-intercept, or the vertex and any point, to write our vertex form and then expand that into standard. So you know how to do that by now as well. The last one says to write this one in vertex form by graphing. So interesting, you can do that completely without graphing using the -b over 2a shortcut, but they want you to do it by graphing and write it from the graph. So you can plug it into a calculator or into Desmos if you don't have a calculator that graphs, and then use the same process we did for these graphs here to figure that one out. So, and that's it.